So now we see the problems based on milli equivalents and their equivalents, so which is a part of stoichiometric problems. Okay. So see the first one. So what volume of 0.1 m potassium permanganate is required to oxidize 100 milliliter of 0.2 m ferrous sulfate in acidic medium? Here the KMnO4 acts as oxidizing agent. FeSO4 is oxidized. Ferrous sulfate, we know the oxidized to ferric sulfate. Here made a oxidized part is Fe plus 2 is oxidized to Fe plus 3. And MnO4 minus is responsible for its oxidation. So MnO4 minus itself it is reduced. So it is given the acidic medium. So we must know that the acidic medium, what is the change in permanganate ion? The permanganate ion changed to Mn plus 2 in acidic medium. We know that. So there is a change and therefore there is a N factor is equal 5. The oxidation number of manganese is plus 7 and plus 2 N factor 5, we know that, an acidic medium. Next, what about FeSO4? Here ferrous sulfate flow involved part is ferrous. The ferrous is changed to ferric and here N factor is 1. So these two are reacted completely means not only these two, for any two reactants which completely reacted means they are exactly equal in their milli equivalents. Then only there is a complete reaction takes place between them. So here the complete reaction takes place. So we can equalize their milli equivalents. So therefore we can say the milli equivalents of the reacted part MnO4 minus are exactly equal to milli equivalents of Fe plus 2. Milli equivalents means normality into value in milliliters. So normality into value in milliliters. That's called milli equivalents. So normality. So here it is given in terms of molarity. So normality is equal to molarity into N factor. So what is the molarity? 0.1 m. What is the N factor for it? 5. Volume. What is N2? N2 means molarity, it's 0.2. It's N factor 1. What is the volume? We given as 100 milliliter. Now calculate the V1. Is equal to 40 milliliter. So the amount, nothing but the volume of potassium permanganate of 0.1 m required for the complete oxidation of ferrous sulfate into ferric is 40 milliliter. Okay, take it. See the next one. What volume of 0.2 m potassium dichromate is required to oxidize 50 milliliter of 0.3 m sodium oxalate in acidic medium? It is exactly similar to the earlier problem, but here the changes are oxidizing agent and which is oxidized. They are only changed. They are also given in terms of milliliter, so we must equalize their milli equivalents. If there is no volume terms are given, at that time we need to equalize their equivalents. Here it is given in terms of volumes, so we must equalize them, or we can equalize them in terms of milli equivalents. Here what is oxidizing agent? Potassium dichromate. The involved part is dichromate ion. So it is known that the dichromate ion is oxidized to chromium ion. Here its oxidation number plus 6 of chromium changed to plus 3. Such type of two chromiums are changed by 3, so the N factor is equal to 6. Next, what is the oxalate? The oxalate ion in acidic medium. Actually, dichromate ion in any medium change it to chromium ion. There is a specific, no specific medium is there for dichromate. So, but for oxalate there is a specific medium should be there. Its change is based on medium. Here it is given acidic medium. In acidic medium, it changes it to carbon dioxide. So what is the N factor now? Here carbon oxidation number 3. Here carbon oxidation number 4. 2 like carbons are changed from +4 to +3. 2 such carbons are changed from +4 to +3. So therefore N factor equals 2. Means there is a changing of 2 electrons. So it given in terms of values, and both are reacted completely. So both are reacted completely means their equivalent, their milli equivalents must be equal. So therefore milli equivalents of dichromate are totally equal to milli equivalents of oxalate. Milli equivalents means N1V1 equals N2V2. Again N1, it is given in terms of molarity means molarity into N factor. We need to find the value. So N2, this is only 0. In terms of molarity, what is N factor? 2. What is the value is given? 50 milliliters. So same, we need to find the value V1. Okay. Here it is equal to 25 milliliter. So the value of potassium dichromate is an oxidizing agent required to complete oxidation of sodium oxalate required is 25 milliliter. Okay, take it. See the third problem. 5 milliliter of solution of hydrogen peroxide liberates 1.27 grams of iodine from an acidified potassium iodide solution. So we need to find what is the molarity of hydrogen peroxide. An important one, this is totally different when compared to the earlier two problems. Here the 5 ml solution of hydrogen peroxide liberates iodine. So by reacting with potassium iodide solution in acidic medium. So in the earlier problem it is given only about the reactants. There was only information about 2 reactants. Directly we compared the milli equivalents of the 2 reactants. But here 2 reactants are given and the product is also given, and the details of one reactant and the details of products are only given. The details of other reactant is not given. Means here you see the hydrogen peroxide acts as oxidizing agent. It oxidizes potassium iodide. Only these 2 reactants, these 2 are only reactants. In earlier problems only reactants are only given. But here information is given about the product iodine. And again here important thing is when there is only 2 reactants only given, we compared the nothing but we equalized the milli equivalents of that 2 reactants. Here we need to remember that here the products are also given means we can equalize the products milli equivalents also with the reactants milli equivalents. Here the reactant is hydrogen peroxide, the product is iodine. Means see here we give a relation. The hydrogen peroxide is oxidizes potassium iodide into iodine. So D2 are the reactant, this is the product. So potassium iodide oxidizes hydrogen peroxide oxidizes potassium iodide into iodine an acidic medium. Therefore, we can write milli equivalents of hydrogen peroxide are equal to milli equivalents of potassium iodide and totally equal to milli equivalents of iodine. So the information is given only for peroxide and I2. Therefore, we can write milli equivalents of hydrogen peroxide are exactly equal to milli equivalents of I2. So milli equivalents, we know that. So from here the problem is similar to the earlier one. N1 V1 equals N2 V2. N1 again, what is the molarity? It's given. So we need to find the molarity actually in this problem. Molarity is same one. So what is N factor? The hydrogen peroxide oxidizes this to iodine. Oxidizes this potassium iodide into I2 means it also gains 2 electrons here. N factor 2. See, the hydrogen peroxide changed to H2O. Here N factor is equal to 2 in acidic medium. Its value in family. So what is the N2? It's the iodine is given in terms of weight. We need to find out the normality. At least molarity is given into N factor. We are able to write the normality. But here normality is not given. Even molarity is not given. Only its weight is given. So simply we can calculate its normality with the help of that weight value. So what is the normality of any compound? Its weight by equivalent weight. Equivalent weight means molecular weight. So molecular weight. Here we are calculating for 2 iodines by N factor. N factor, how many electrons are changed here means see in potassium iodide I minus becomes I2. The balancing purpose to 2I minus becomes I2. So that is here also N factor 2. So 2 into 1000 by value in milliliters. This is normality. So this is V2. V2 is nothing but volume of this iodine. So we will get cancelled here. So what is the become 1.27 means by multiplying with it M1 is equal to 1. So the molarity of the hydrogen peroxide is 1. This is molarity of hydrogen peroxide is 1 moles per liter. So here also another method. So normality we directly change it into molarity. In other terms, at first we can calculate only normality, and afterwards with the help of normality molarity relation we can calculate the molarity. But here the molarity of hydrogen peroxide in this reaction is 1 moles per liter. Okay, take it. See the next one. It is somewhat different from earlier 3 problems. So how many moles of potassium permanganate will be required to react completely with 1 mole of potassium oxalate in acidic medium. So potassium permanganate in acidic medium, we know that. Oxalate in acidic medium, it is also changes, we know that. Here important one is, here also the potassium permanganate completely oxidizes the potassium oxalate. For any complete reaction, we can compare the milli equivalents. Nothing but their milli equivalents must be equal for the completion of reaction. But here it is not given in terms of value. When there is a value is given, then only we can equalize their milli equivalents. That is N1 V1 equal to N2 V2. But here only given in number of moles. How many? We need to calculate the number of moles of permanganate for the reaction of K2C2O4 of 1 mole. I mean both are given in terms of moles only. The given information in moles, we need to find out the manganate, potassium permanganate in terms of moles. Then if there is no volume, if there is no volume terms are given, just equalize the equivalents. Okay. First we see the N factors. The oxidation number of manganese is plus 7 to plus 2, 5. It is in acidic medium. For C2O4 minus 2 becomes CO2, 2 CO2. Here carbon oxidation number plus 4 to plus 3, plus 4 to plus 3. So 2 such carbons are there and factor is 2. Here there is no volume terms are given. No volume terms are given, therefore equivalence of MnO4 minus is exactly equal to 1 equivalent of oxalate. So equivalents are equivalence weight. Sorry, equivalence means weight by gram equivalent weight. It is also weight by gram equivalent weight. Here in factor 5, here in factor 2. So if you write the total term for number of equivalents, equivalent means weight by gram equivalent weight, nothing but weight by molecular weight by n factor, weight by molecular weight by n factor. So now it is equal to 1 equivalent, its n factor is 1 by 5 moles of MnO4 minus is equal to, nothing but is required 1 by 2 moles of C2O4 minus 2. Means there is a 1 by 4 moles of MnO4 minus are required for 1 by 2 moles of C2O4 minus 2. So this is according to these n factors. But here given terms are different. Here given only 1 mole. According to this relation, half mole of oxalates required 1 by 5 moles, or nothing but we will do it for 1 mole. Okay. Here it implies that 1 by 2 mole of C2O4 minus need how many moles of MnO4 minus? That is 1 by 5 mole of MnO4 minus. 1 by 2 moles required this. So what about 1 mole? 1 mole C2O4 minus 2 need 1 by 2 need 1 by 5. So 1 mole need 1 2 by 5 mole of MnO4 minus 2. So this is a way to calculate. The number of moles is 2 by 5 moles of MnO4 minus is required for the complete oxidation of potassium oxalate of 1 mole. The 2 by 5. Here the 2 by 5 moles is the answer, or nothing but 0.4 moles of MnO4 minus is required. Here the difference is only we compared here the equivalent weight, whereas in earlier problems we equalize the milli equivalents because the volume terms are given. Here there is no choice to calculate the milli equivalents as there is no volume terms are given. Okay, just take it. See the similar problem. How many moles of hydrogen peroxide? Here hydrogen peroxide always here works as oxidizing agent. Okay. So there is a possibility for hydrogen peroxide works as reducing agent also. Here how many moles of hydrogen peroxide will be required to react completely with 1.5 moles of tetrahydroxy chromium potassium 1. Tetrahydroxy chromium potassium. Sorry, its name will be treated as potassium tetrahydroxy. So the first term will be given at first time. So potassium tetrahydroxy chromium 1 ion in a basic medium. Okay. Here the changes, the main important is the hydrogen peroxide, we know its N factor is 2. And we need to know this potassium tetrahydroxy. Here oxidation number of chromium, it's potassium 1, chromium X, OH always minus 1, it's minus 4 equals 0, here X equal to 3. So here the oxidation number of chromium is plus 3. Just now we said it is 1, it's not a 1, it is the oxidation number is 3. It can be named as potassium tetrahydroxy chromium. What is the oxidation number of chromium here? 3. So it's a complex compound, so naming as potassium tetrahydroxy chromium 3. Okay, the 3 indicates the oxidation number of this chromium in this compound. Okay, this is changed to this potassium tetrahydroxy chromium 3 in the presence of hydrogen peroxide is changed to chromate ion. Here it is Cr plus 3, it changed to chromate ion. So what is the change in the oxidation number? Here it is 3 already given. This X minus 8 equals minus 1. So here the number of electrons changed is here the number of electrons changed is so 3 7. Here main important one is chromate ion means always CrO4 minus 2. So that is so minus 2 it becomes 6 because chromium cannot be existed 7. So the difference is just 3. Okay, plus 3 becomes plus 6. How it's possible? By losing 3 electrons. Mean here n factor is 3 electrons. And we know that hydrogen peroxide, it is oxidizing. Here what is oxidizing agent? Hydrogen peroxide is the oxidizing agent. Though hydrogen peroxide is oxidizing agent, the n factor of hydrogen peroxide is H2O, 2 electrons. So here n factor is equal to 2. Here value terms are not given, so we are they both are completely reacted, means any two reactants are completely undergoes reaction, means we must equalize nothing but they are exactly equal in their equivalent weights. So therefore one equivalent weight of hydrogen peroxide is exactly equal to one equivalent weight of potassium CrOH, take it 4. So equivalent weights means nothing but the total calculation, the weight by molecular weight by n factor. Here n factor is 2, so that becomes 1 by mole, 1 by 2 mole is equal to its n factor 3, so that is 1 by 3 moles. Means here we need to calculate hydrogen peroxide. So 1 by 2 moles of hydrogen peroxide is required to oxidize 1 by 3 moles of potassium, this complex compound. So 1 by 3 need 1 by 2 moles of hydrogen peroxide. So what about 1.5? Okay, this see 1 by 3 need 1 by 3 of potassium complex, nothing but 1 by 3 of Cr plus 3 need this is 1 by 2 of hydrogen peroxide, nothing but 1 mole of chromium plus 3 is need 3 by 2 moles of 3 by 2 moles of hydrogen peroxide. So 1 mole required 3 by 2 moles of hydrogen peroxide. Then what about 1.5? One mole of Cr plus 3 need 3 by 2 mole of hydrogen peroxide. Then what about 1.5 mole? So then that is equal to, so 15, so that exactly equal to 9, 1.5 into 1.5 exactly, okay. That is 2.25 moles. The 2.25 moles of hydrogen peroxide. 2.25 moles of hydrogen peroxide is required for the complete oxidation of this potassium complex of 1.5 mole. Okay, let's take it. Okay, see the next one. So what volume of 0.1 m potassium permanganate is required to oxidize 100 milliliter of 0.3 m ferrous oxalate. Here it is important one, ferrous oxalate in acidic medium. We know that N factor for potassium permanganate, that is 5. So what is N factor for ferrous oxalate? So what is the importance of this compound? So generally this is the best example for the compounds in which both cation and anion undergoes oxidation. Here in FeC2O4, Fe plus 2 becomes Fe plus 3, and C2O4 minus 2 oxalate becomes 2 CO2. Here it is a 1 electron change, here it is totally 2 electrons. So both are oxidized. These two are oxidized by potassium permanganate. So the total for N factor it is here 3 electrons. N factor is 3. And this problem again there is given in terms of volume. So in terms of volume, so we know that the volume is given, the two reactants are completely reacted. So then we can write nothing but we can exactly equalize their milli equivalence. So here we can write milli equivalence of permanganate with milli equivalence of FeC2O4. So milli equivalence we know N1 V1 equals N2 V2 for N1. So what is the normality of this? 0.1 into its molarity is given. Normality equal molarity into its N factor. What is the value? We need to find the value. What is the normality of this one? 0.3 molarity into what is N factor? That is 3. The given value is for that is 100. Therefore V1 equal to and 1 into 5. So therefore equal to so there is a requirement of 180 milliliter of potassium permanganate. 180 milliliter of potassium permanganate is required to total oxidize the ferrous oxalate of 0.3 m. Okay, let's take it. Okay, let's see the next one, which is exactly reciprocal, opposite to the just earlier problem. In that problem, iron oxalate was oxidized by potassium permanganate. In the same way, here it is asked that how many moles of ferrous oxalate required to reduce the 2 moles of potassium permanganate in acidic medium. The medium is same one, but at that time the earlier problem asked that potassium permanganate required for ferrous sulfate oxidation. Here it is given that the moles of ferrous oxalate to reduce potassium permanganate, but here in terms of moles. In terms of moles and not in terms of volumes. Means we need to equalize their equivalence. Nothing but they are equal in their equivalence. So we know that FeC2O4 and factor equal 3 as Fe changed to Fe plus 3. and C2O4 minus 2 changed to total M factor 3, and we know that MnO4 minus 2 to Mn plus 2, that is plus 7 here, in fact is equal to 5 electrons. Both are completely reacted means we need to equalize the equivalence. So one equivalent of FeC2O4 equal to one equivalent weight of MnO4 minus 2. Here it is equivalent weight by calculation. Here we get n factor, that is 1 by 3 moles of this FeC2O4. That is 1 by 5 moles. Here we need to, here from these clues, these hints, we can write 1 mole of MnO4 minus 2 required, 5 by 3 moles of ferrous oxalate, 1 mole of MnO4 minus for its reduction. It's need 5 by 3 moles of FeC2O4. He asked that what if for 2 moles. So therefore, for 2 mole of MnO4 minus 2, what is the required FeC2O4? So that is equal to 3.333 moles of FeC2O4. 3.33 moles of FeC2O4 is required for the complete reduction of potassium permanganate of 2 moles. Okay, just take it.